Hi, I'm Liam, and this is my homemade mechanical relay project. Sitting in front of us here is the relay, and I'm going to point out a few important parts before talking about them. This big thing here made out of wire is the copper coil, and this is the whole power behind the relay. Down here on the right is the switching mechanism, which I'll talk about later, and in the back is the driving board. And in here, there's a MOSFET that's used to switch the relay because it has a massive current draw. And then dotted all around, there's a bunch of wires, which there's not really too much you can do about, but they do look kind of bad. Here's an example of the relay working to turn off and on these LEDs. So as you can see, when you flip the switch, the relay either moves up or down depending on what it currently is, and the LED that's on turns off and the LED that's off turns on. Now, unfortunately, the contact between pads is not perfect and the LEDs do flicker quite a bit, but it still works and I'm happy with it. Here's an example of an Arduino being used to switch the relay. It's currently running the blink sketch, so every half second the relay will change state, but the Arduino is not actually directly powering the relay because of the current draw. So instead, it needs a driver board. So as mentioned, and as demonstrated by this clip, the coil when turned on draws around 1.4 to 1.6 amps of current, and this is well out of the range of a microcontroller. If you try to switch this with an Arduino, you would blow it up. So instead, the Arduino goes into this green wire here, which is its input, and that switches to MOSFET, which you can see. And the MOSFET is wrapped in this copper piece, or brass. I'm not quite sure what it is, but it's acting as a makeshift heatsink, and it does the job, because without it, the MOSFET also overheats. But at least this way, you don't have your microcontroller blow up. So the output from the MOSFET then goes into the coil itself, where it switches to either the down or up state depending on the power. I've taken off the case here to better explain the relay, so let's move that into view. And beginning with the switching mechanism, this is how it works. So, as you can see, there's a purple arm here attached to the top of the coil. And what happens is when the coil is powered on, it lifts up the arm, which changes the connections of the relay. As you can see here, there is aluminum tape on the top and bottom plates, and then the arm itself has aluminum tape on it as well, and that's attached to these copper wires. And when you move the arm, you make physical connections between the aluminum tape on the arm and the either top or bottom plate. Let's take a step back and discuss why the arm actually moves when we put current through the coil. So this is due to electromagnetism. And one of the fundamental laws of electromagnetism is that electric fields create magnetic fields. However, this is normally very, very small. But when we wind so much wire around such a small space, all the small magnetic fields add up to create one big magnetic field. So essentially, the coil then turns into a magnet, or an electromagnet. In the arm is a hidden permanent magnet, which when the coil is turned on, is either attracted to or is repelled from. And when it's repelled from the coil, this lifts the arm to get the magnet away from the coil.